Hey Kyle, look, I got this 10,000 new watch.
Oh, dude, that's so freaking great.
I know, right?
I don't know what I would do if I had that much money. Like, that watch is so...
Oh, That's right.
My name's Emmy, and I'm reporting from Cushing Academy News. Here we're on the scene of the fresh new murder, which appears to be a gunshot wound. Here we have our poor victim laying in the snow, and there's no one else around here except for one of his friends who was with him during the murder.
I don't know what
Kyle?
happened.
Do you know what happened, Kyle? We're so sorry for your loss.
Oh, he's dead. He stole his watch. Oh, God.
The watch will be missed. Talking to the poor victim, we've realized that this case is much more serious. Here is our crime scene investigator, Carlos.
Hi. Yeah. We're thinking of approaching this in a different way this time. As you see, there's a lot of blood on the snow. The victim's dead. I think we might be taking a lot of blood samples. We have to figure out the velocity of the bullet, what gun was used in this murder. It looks like this guy had a hit on this man for his watch, clearly, because his watch is gone, and we had the witness say that it was all over a watch. So we're gonna take this back to the lab and figure things out. We're gonna have to do a few equations, figure out what we're gonna do and how we're gonna proceed with this.
Thank you, Carlos. Now, to a video showing what our crime scene investigators do to solve a murder like this.
Hi, my name is Fergus, and I work for the crime scene investigation in Cushing Academy. And we're trying to solve this case that happened in Cushing Academy. But first, I want to talk about some brief history about forensics. So the first actual forensic scientist was Archimedes. He proved his king crown was not pure gold by measuring its density. And that was our first forensic scientist. And the second most significant one was Sir Arthur Conan Doyle. He was the author of Sherlock Holmes. It was written in the late 19th century. He used science to solve problems. Yeah. And also Sir Francis Galton, who was the first one that found fingerprints are unique, so they can use it to help in forensics. And also Edmund Locard, he established his first laboratory dedicated to crime analysis, and it spread all over Europe. And that's it, I think.
Hi, my name is Emmy Strasdis, and I work for the crime scene investigation at Cushing Academy. I'm trying to solve the murder that took place a couple days ago, but I'm going to talk about what ballistics is and what we do to solve a murder like this. What is ballistics? Ballistics is a term that is used to refer to the science of flight of a path of a bullet or an arrow or something like trajectory. Tracing the path of a bullet can reveal which direction that the bullet was fired in, and a higher speed means that there is more energy placed on the bullet. Frictional resistance of air along with the pull of gravity will affect the flight of a bullet, and a bullet that is fired from a rifle will have more energy than a bullet fired from a handgun. But we're going to do a lot of calculations to figure out what type of gun was used, which Carlos will talk about later. The stronger the firing chamber, the more it will be able to withhold a large amount of increased explosive powder. A longer barrel will also produce a faster moving bullet because the explosive energy that passes to the bullet depends on the mass of the bullet multiplied by the force of the explosion multiplied by the time the force is applied. Most times on crime scenes, the bullets are in pieces or not intact, making it more difficult for the investigators to read into the bullets. But in our situation, we are lucky because we found the bullet completely intact. Thank you.
Go.
Alright, I'm lab scientist Kyle Kovac. We've been investigating the crime, and we found out some stuff about the gun and the bullet and the mass of the person. We're using a non-traditional way of how to figure out who did this and like what kind of gun they were using. Usually forensics would be like ballistics and other stuff like that, but on this time, since we've got so much information on the gun and the bullet, we're gonna try and figure out the type of the gun and how it was used. So what we have first is the mass of the bullet, which is 0.02 kilograms, the mass of the victim, the initial velocity, because our specialists found out a way to simulate what happened. Like we're assuming the person was standing still, and the recoil of the gun. What we did here was we have the mass one and the velocity one, and you just plug in the values. What we're looking for is velocity 1. So we plugged in the value of the bullet, the mass of the person, the initial velocity, the mass of the bullet again, the person's velocity, and then the recoil of the gun. And then we plugged in, we solved this, so it comes down to the next part of the equation, and it goes further down, and then you divide by the mass of the bullet to get initial V1 alone, and then you divide it by what this came out to, which is 8.84, and then you divide it by the mass of the bullet, and then you get the initial velocity of the bullet of the gun. The velocity of the bullet, we calculate for the time that it took for the bullet to travel the distance, which is approximately 2 feet from what our people say, into the victim of the shooting. Like the equation we use to find the time is the velocity equals the distance divided by the time. We plug in the velocity, which is 442.402, and then we plug in the distance, which is 0.619 meters, and then we would solve for this, and then we get the time it took for the bullet to enter into the victim, and that comes out to 0.0014 seconds. And now we use another equation, which is the change in force. The force and the change in time equals mass change in velocity. So we plug in the time here, and we're looking for the force, and that equals the mass of the bullet and the velocity of the bullet. And now we divide by the time, and we also divide the other side by 8.84 by the time as well, because that's what this comes out to. And then we get our answer, which is 6,320.02 newtons.
Hi, this is John, the scientist, just like Kyle, the scientist. We got a whole bunch of information on the bullet and the scene that happened here at Cushing Academy. Due to all the information we got from our detectives, the investigators, the police, the surveillance cameras from the town, we got the initial velocity of the bullet. We have the force of the bullet to the person, from the bullet to the person. We basically have a lot of information that can give us the type of gun that was used. So now, due to all that information, we have a new equation that is kinetic energy equals half times mass times velocity squared. Kinetic energy equals half of the mass of the bullet, which is 0.02, times the velocity, which is 442.402 squared. Then you square, pull out the math, you do half of 0.02 is 0.01, and then you just multiply out to 442.402 squared, and that gives us the kinetic energy of the bullet, which is 1,957 joules. Then to find out the distance of the barrel of the gun, we came out, since kinetic energy equals work, and work equals force times distance, kinetic energy is the same thing as work, so 1,957 equals 6,320.02, which this number we got from Kyle's work that he did over here, giving us the force, times distance. Then you have to do 6,320.02 divide that from 1,957, and that gives us the distance of the barrel of the gun, which is 0.31 meters, which equals the distance of the barrel of the gun. Yeah. Alright, Ferguson, so you gave us, from what you told us, this gives us all the information that you're saying that it's in Bob's store. And where's Bob's store located, Kyle?
It's located in Ashburnham, Mass.
Ashburnham?
Yeah.
Ashburnham. Oh, and that's exactly near the store, so near the school of the shooting, huh? Okay, so now since there's only it's only 30.31 meters of the barrel of the gun. So should we go interrogate the owner of that store?
Yes, sir.
Sure. All right, awesome. Thank you.
Nice to see you. We're doing an investigation on murder, like a very serious matter. Well, what we want to know is, has anyone come by here buying a customized gun where its barrel was 0.31 meters and it shot at a velocity of 442.402 meters per second?
We have a couple people about this gun, but like, if you show me your face, I can try and remember.
Alright, so
About this gun.
we have a few suspects here. We have suspect 1,
Okay.
suspect 2, and suspect 3.
It's probably suspect 2. It looks
Suspect 2
more like the one that came by yesterday.
came by yesterday.
Yeah.
Okay, good to know. What gun did he buy exactly?
He actually bought. Oh, yep, it's this gun that he bought. It's a custom made gun.
Alright. And you said it was suspect 2 that bought this gun?
Yeah, probably.
Alright, thank you.
Hello, are you Carlos?
Yeah. What? What's going
We're
on?
under arrest now.
Well, what have I done?
You're accused of the crime of murder. Our physics equations have proven that you have bought a certain gun used at the crime of the scene. You have the right to remain silent, and you will be under arrest for life.
Oh crap! They caught me, man. They caught me. I'm done. Oh, Mama, where you at?